Let's talk about the quotient rule now. Sorry I don't have a fun story about a growing volcanic island or anything. There probably is some way to geometrically visualize this, but it's just so complicated. So we'll just lay it on you. So the derivative of f over g is g times f prime minus f times g prime. And that's hard to remember maybe, but there's a nice little rhyme that goes with it, at least in English. I would love to hear it in other languages if you know it. It's low d high minus high d low, square the bottom, and off you go. So low means the denominator, g, in the original function. High means the original numerator. So low, and d means the derivative of. So the low thing, g, times the derivative of the high thing, minus the upper thing, f, times the derivative of the low thing, which is g, and then you square g, and off you go. So some things to note. The order of subtraction is important. Of course, if you mix up your subtraction, you're going to get these negative of what you should get. So you can't just use high times d low over here and vice versa. Some people mess that up. Notice that we're not taking g prime in the denominator in the answer. It's just g squared. So not taking any derivatives in the denominator. And you might need, if your f or g has an add or subtract in it or a negative sign, you might need to protect that using parentheses so order of operations all still gives you the right answer. So you might want to think of it as low d high minus high d low, square the bottom, off you go, but with each term protected by parentheses. So our first shot at trying it, here I'm proposing x squared over x to the 7th prime. So I recommend writing out the generic form and then under that writing the specialized version for this. So pause the video and do that. Okay, welcome back from pausing. So we've got g times f prime minus f times g prime over g squared. And we're thinking f is x squared and g is x to the 7th. So that would be x to the 7th times x squared prime minus f is x squared times x to the times g prime. G is x to the 7th, like that. Didn't really need that parentheses, but it doesn't hurt. And then g squared, well, g is x to the 7th. Let's try that again. X to the 7th, and then squaring that. Right? And let's just at least simplify until the primes are gone. So we get x to the 7th times 2x minus x squared times 7x to the 6th. If you have x to the 7th squared in the denominator, that's x to the 7 times 7, or x to the 14. And in this case, I just want to try what happens if I simplify all the way. So this ends up being 2x to the 8th. This ends up being 7x to the, this was the 6th. So 2 and 6 gives me 8th, or x to the 14th. So I end up getting 2 minus 7 x to the 8th over x to the 14th, which is negative 5x to the negative 6. There we go. Could we have gotten negative 5x to the negative 6th any other way? So let's kind of separate these. Well, I could have simplified to begin with. I could have said x squared over x to the 7th is x to the negative 5th, because it's x to the 2 minus 7. Take the derivative of that. Well, we know the power rule. This is x to a constant power. In theory, all we know is that the power rule works for positive integers. This is a negative integer, but what happens if we try it? We'd copy the negative 5 out front and then do minus 5 minus 1, which would be minus 5x to the minus 6, which works. So I chose this example because you can do it with the quotient rule without too much trouble, and you can also simplify it ahead of time. and then just do the power rule on it. So what this is learning, or what this is teaching us, it's not a grand coincidence, is that the power rule that we did here works for negative integers as well as for positive integers. Remember, we're calling that the constant power rule. All right, so let's try another example. When we were doing the product rule before, we did decaying or growing sine wave. Let's try a surge curve this time. Remember, those look something like this. And the formula that I gave last time was t squared e to the negative t. We actually don't know how to handle e to the negative t at this point, but we could write it as t squared divided by e to the t, moving a negative exponent term into the denominator and canceling the negative. So now it's a quotient. So go ahead and take the derivative of that, t squared over e to the t. So pause the video, work out the whole quotient rule. Ready? Okay, here we go. So let's rewrite the quotient rule. Low d high minus high d low, square the bottom, and off you go. We're thinking of t squared as f, and we're thinking of e to the t as g. So we're doing g, so that's low d high minus high, and then low, and take the derivative over e to the t squared. And let's at least simplify until the primes are gone. So e to the t, and then what's the derivative of t squared? 2t minus t squared. What's the derivative of e to the t? E to the t. Now you could leave this in the denominator as e to the t squared. You could write it as e to the 2t or e to the t squared. Or you could write it as e to the t, and then cancel the e to the t's in the top with one of the e to the t's in the bottom. Either way is fine. At this point, we've done all the calculus, and all that's left is algebra, so you can do that on your own if you want to.